This is the AQA 2020 Further Maths AS paper, and we're looking at the vector question. So we're told at the start of the question we've got two lines, and we're given the Cartesian equation of one and the vector form equation of the other. And part A asks us that when these two lines are parallel, show that one constant that we've got in the direction vector is -11, and we're asked to find the other constant. Now, if two lines are parallel, then one direction vector is a multiple of the other. So we're told the direction vector of line 2, but we need to find the direction vector of line 1. So for line 1 we're given the Cartesian form, and so the Cartesian form equates an expression in x with an expression in y with an expression in z. But what we need to know is that these are also equal to the scalar multiplier of the direction vector, which we'll call lambda. So that means lambda equals that first expression, lambda equals the second expression, and the third. And so what we want to do is change the subject to make x, then y, then z the subjects. So this one, let's see, 1 minus 2y is 4 lambda. So 1 minus 4 lambda over 2 is y. So this one, x will equal 3 lambda plus 2. So for line 1 we have the vector form as in, so the x is 2 plus 3 lambda, y is a half, 4 divided by 2, and then just minus 1. So now we've got the vector form of line 1, then we can consider the direction vectors. So we've got the direction vector of line 2 and line 1. And what we said is that one will be the multiple of another. So we can say that is the direction vector of line 2 is equal to some multiplier times the direction vector of line 1. So in the case, in the x direction, then 12 equals 3k. Now we can show, we should be showing that a is equal to -11. So k is 4, so it's, and so a equals that's -8, take away 3, it is indeed -11. So we've shown it to be true. And finally 2b equals k times -1. We need to find out what b is. So 2b is -4, therefore b is -2. So that's the case for when they're parallel. Let's have a look at part B. So we're told we now have a different case. So we've still got the same lines with the same equations, but what's going to happen is the values of A and B that we just found for when it's parallel, they will be different. And we're told that they intersect at exactly 1 point. So if they intersect at 1 point, then there's going to be a value of mu and lambda, which for in each x, y and z direction, each x, y and z will equate to each other. So just reminding ourselves, there's the lines that we're interested in. So we've got for line 1, that is and for line 2 so what we know is for a certain value of lambda, 2 plus 3 lambda is equal to minus 7 plus 12 mu. And we also know that for the same value of lambda, half minus 2 lambda, that's equal to 4 plus mu times a plus 3. And for the same values, 0 plus minus lambda is equal to minus 2 plus mu times 2b. So we're told that b is 3, so 6 mu. So we've got simultaneous equations here, so we can use equation 1 and equation 2 and solve for lambda and mu, and then substitute them into the remaining expression in the y direction and solve for a. So we can see from 2 we can multiply through by minus 1. We've got a value for lambda. We can then substitute that into equation 1. So 2 plus 3 lambda, lambda is that, equals plus 12 mu. So let's see, we've got 2 plus, that's going to be 6, is 8. Bring the minus 7 over to this side, that will give us 15. And here we've got 3 times minus 6, that's minus 18. If we add it onto both sides, then that makes 30 mu. Therefore mu equals 0.5. Now we can substitute this into an expression. Lambda equals 6 mu, and therefore lambda equals 2 take away, and so lambda equals minus 1. So given those values of mu and lambda, then we can go back to our equation in the y direction. So half minus 2 lambda, and we're going to solve for a. So lambda is minus 1, so half take away 2 times minus 1, so that's half plus 2. Mu is 0.5. So that's 2.5. We'd take off that 4 off both sides. That leaves us with minus 1.5. So that's 0.5a plus 1.5.